Hey guys, Mrs. Hedrick here. Okay, so we're ready for April 15th math lesson today. This is Math 6. We're in lesson 22. For today, you're going to need your instruction book, a pencil. If you have a calculator, grab a calculator. And then you're also going to need your notes and any note-taking supplies, but we're going to do that at the end instead of at the beginning this time. Okay? So if you need to go get anything, we'll need our instruction book, a pencil, calculator if you need it, your spiral notebook or the paper that you wrote on yesterday, and any supplies to write your notes with. So go ahead and get those, pause it, come on back. Okay? Okay guys, we're going to start on page 224. And I already drew the picture. Well, first of all, let's just say that last night's homework, you guys had practice and problem solving 249 and 250. So if you go to Google Classroom, well, you were already there, you will see the homework answers. That's a document that I attached, so you can go in and check your answers. The answers are there for all the homework, so please don't copy. You're not going to learn anything that way, but all the answers are there, so after you finish your homework, or if you get stuck, you can always go check the answers, see if you were right, or see if you can figure out how to do the problem. Okay, remember I have office hours, so if you get stuck or you want me to go over something with you, please come in on office hours, and I'm happy to do that. Okay. All right, so we are on page 224. This is where I would ask a classmate to read the question in the yellow box, but let's do it together. Read along with me. In art class, Swati created a trapezoid made of smaller trapezoids that are all the same size and shape. If the height of the large trapezoid is 4 inches and the bases measure 5 inches and 10 inches, what is the area of the large trapezoid? What is the area of one of the small trapezoids? Okay, so if you're looking at your book, at the top of the page, you can see the blue triangles and then that red triangle that outlines them all. This is pretty cool. I'm guessing more stained glass. But let's go ahead and take a look at Picture It. Let's see what they did. So you can draw the large trapezoid and label it with this information. And so I have that information here. They talked about the bases. So this sits on the bottom. This is one of the bases, 10 inches. And this is actually another base. If you flipped it upside down, you could do that. This is 5 inches. And then the height is 4 inches, right? And I know this is the height. It's a dashed line with the right triangle. So that means that that's a 90-degree angle. Nice and straight and tall, right? This is the height. Okay. Now, let's go to the model it. You can separate the trapezoid into 2 triangles and 1 rectangle and label their dimensions. Okay, so look at what they did. They came through on the other side. They added their dashed line, a right angle to show that that's straight up and down. This is also 4 inches, correct? So now they've divided this. Can you see it? I've got a rectangle in here, and I've got a skinny triangle here, and a skinny triangle here. But what's interesting is they changed this number. If you notice, this distance is 5 inches, so this distance is 5 inches. Okay, well wait, I just had 10 and I erased it. So now if this portion is 5, that means this little piece and this little piece, I'll pretend I drew those evenly, those would also be 5 inches. So we can do a little math and figure out that this is 2.5 inches and this is 2.5 inches. Now, it may have taken us a little minute to figure that out, but it's okay. If I add these 3 numbers together, they would equal 10 inches, okay? All right, so let's keep going. Let's go down to the solve it. Okay, you can find the area of the triangles and the rectangle to help you solve this problem. Look at your notes. You wrote these yesterday. The area of a triangle is base times height divided by 2. The area of a rectangle is base times height. Okay, so now let's go on to the next page. Page 225. Look at the model it. So that's what I have drawn here. Okay, what can you say about the 2 triangles that are part of the trapezoid? What do you notice about these 2? You might want to look at your book. My picture isn't perfect. What do you notice about these 2 triangles? what would you write? Go ahead and say it out loud. Okay, would you say that the triangles are the same shape and size? Mine don't look it, but we'll pretend. So these are the same shape and same size, so it's the same triangle. Okay, let's go to number 10. What do you know, or excuse me, how do you know that one of the sides of the right triangle is 2.5 inches? Well, remember we talked about that. How did I know that this was 2.5? That was kind of hard, wasn't it? This whole distance was 10. I know that this distance is 5. So I did 10 minus 5 is 5, and then I split it equally among the triangles. So 5 divided by 2 is 2.5, 2.5. So then if I add these up, they equal 10. That can be tricky, so we have to be careful, okay? Number 11, explain how to calculate the area of the large trapezoid. Show your work. Okay, let's find the area of this. Okay. So, let's see, let's do the rectangle first. That will be the easiest. Let's see, how about red? So I know that for a rectangle, area equals base times height. So what's my base? Area equals 5 times, what's my height? 4. What's 5 times 4? 20. So this is 20 inches. Do you remember? Inches to the second power, right? Because this is two-dimensional. All right, that part was easy. Okay, now we have two triangles. I'm going to switch colors. How about, let's do triangles in green. Okay, the formula for a triangle is area equals base times height divided by 2. Okay, all right, well, let's look at a triangle. What's my base? Area equals 2.5 times, what's my height? 4. And then I'm going to get that answer and I'm going to divide it by 2. Okay, so 2.5 times 4. Okay, if you have a calculator, grab it. Go ahead and multiply. So let's see. 2.5 and 2.5 is 5. 2.5 and 2.5 is 5. So that's going to be 10 divided by 2, right? Check it on your calculator. Okay, 10 divided by 2. So the area for my triangle is 5 inches squared. Okay, well I did this triangle. What do you know about this triangle? What would we say? It's the same thing, so it's going to have the exact same area. So this one is 5 inches squared. Should I circle them? So now if I want to know the area of this big giant trapezoid, what do I do with those three numbers? I would add them together. Okay, so I've got 5 plus 20 plus 5. 5 plus 20, 25 plus 5, 30. So this is 30 inches squared, this whole giant trapezoid. Okay, and this is the answer to number 11. Okay, so if you need to pause this to write this down on number 11, feel free. Okay, I'm going to keep going. Number 12 says, 12 wants to know, what's the area of one of those teeny tiny trapezoids? Okay, go back to page 224 and take your time. Count how many little teeny tiny trapezoids are inside of the big red one. Okay, I'll count 2. Okay, I think I have my number. How many did you count? I counted 16. Did you get 16? Okay, they're like little teeny tiny trapezoids. They remind me of those pattern blocks, right? The little red trapezoids. If I could put 16 of them together, I could make a big trapezoid. Okay, so if I know that this whole thing is 30 centimeters squared, let's clean house a little bit. Let's just make this look a little easier to read. Let's get rid of some of this. Okay, we'll get rid of all that. Yeah, kind of. Okay, this whole thing is 30 inches squared. And I want to know, can I draw it? How much is one of these? And if I fill this all the way in, there were 16 of them. So what operation is that? The total is 30, and I want to know how much is each one of those little 16 trapezoids. Did you figure it out? Okay, we're gonna do 30 divided by 16. We're gonna take our 30 square inches, oops. We're gonna take our 30 square inches and divide it by 16. Okay, I think it's easier to write it like a fraction. 30 over 16, 30 divided by 16. Let's simplify it first and make it a little easier. What could we divide by? Should we divide by, let's just divide by 2, that's easier. So divide by 2, divided by 2. So that's 15 over 8. That's a little easier. What's 15 divided by 8? How many 8s can you get out of 15 without going? Remember this? Without going over. 15 divided by 8. 2 makes 16, so it's only going to be 1. So if I borrow and I subtract, right, 15 minus 8 should be 7. You have a mixed number. Do you see it? 1 and 7 eighths. So the answer to this is going to be 1 and 7/8 inches, right? Inches squared. That's the area on one of those little teeny tiny parallelograms. That's kind of funny. Okay. All right. Now we're going to switch gears. We're going to go to your notes. Okay. So I have a theory here. Your book wants you to take the trapezoids and divide them into a rectangle and 2 triangles. And we can do that. But then you're solving 3 area problems, right? The triangle, the rectangle, the triangle, and then you have to add them all together. I have the formula that goes a little faster. We only need to solve 1 problem, okay? So switch it up. Go grab your spiral notebook and let's write some notes in. We'll have 1 more formula to add. Okay, friends. Our formula that we're going to add today is the area of a trapezoid. And trapezoids kind of remind me of triangles where the top has been cut off. Sometimes, so they can look like this, right? Like a triangle that you cut the tip of it off. Or sometimes they look like a boot or a little shoe. Those are usually how the trapezoids look. Okay. All right, so this one has a tricky formula, all right? So I'll explain it. Let me draw one of these a little bit bigger. Actually, I'm going to draw the boot. I like the boot. Right, kind of looks like a shoe. Okay, now pretend that fits. All right, so this is a trapezoid. On the bottom here, we're going to call this base 1. And across from that, we're going to call this base 2. Now, if you remember from the iReady lesson that I assigned last week, they talked about how this works, okay? I'm just going to go through the formula today. All right, so this is base 1, this is base 2, and obviously this is the height, right? Because this is a right angle. If this looked like the triangle, it would have that little dashed line, you know, right? If this came out, it would have the dashed line here. Okay, so here is the formula. Are you ready? Area equals, we're going to take base 1, and we're going to add it to base 2. Okay, we're going to add those together first, and then we're going to multiply them by the height. So base 1 plus base 2 divided by height. And then this is where it's kind of like the triangle. Remember, we have a triangle hiding on here. We're going to divide everything by 2. Now, to make this look a little easier to write, you can also write it this way. Area equals B1 plus B2 times the height divided by 2. Okay, that's the shorter way to write this. Okay, so I'm going to leave this one here. I'm going to erase this. Let's do an example. Okay, so I'm going to come into my my trapezoid here. I'm going to take the words off and I'm going to put numbers in. So go ahead and draw this, or you can write on yours. Okay, how about purple? Okay, so let's say base 1 is 12 centimeters. So this distance is 12 centimeters. And let's say this distance up here, we're going to call this, right, base 2, is 6 centimeters. And let's say our height is 5 centimeters. Now, okay, so instead of me cutting this into a rectangle and a triangle, solving two problems, adding them together, I'm just going to solve one problem, but I'm going to use my formula. Okay, let's do it. Area is, what's base 1? So look at what it's sitting on. Usually the bases are at the bottom. Be careful. Sometimes they tip these the other way, trying to be tricky, and the bases are actually on the sides. But you want to set it down. So pretend you were picking up the piece and setting it down so that there's a number on this bottom and there's a number on that bottom. This angle, diagonal, is never going to be a base, right? We talked about that. That's not a straight line. We can't count those. Okay, base 1 is 12 plus base 2, opposite, they're opposite of each other, is 6. We're going to add those two together, and then we're going to multiply them by 5. And once we get that number, we're going to take all of that and divide it by 2. Okay, so we have to follow order of operations. You notice that I put those in parentheses because I'm going to do that first. So what is 12 plus 6? 12 plus 6, 18. Okay, so I need to do 18 times 5. And then I'm going to divide that by 2. Okay, and itchy nose. Okay, 18 times 5. Let's see, 5 times 10 is 50. 5 times 8 is 40, so that's 90. So this equals 90 divided by 2. So if you have a calculator, grab your calculator, that's fine. So double check my math, 18 times 5, I believe that's 90. 90 divided by 2. What's 90 divided by 2? 45. So the area of this, if I put an A, equals 45 centimeters. And remember, this two-dimensional shape, centimeters to the second power. Okay? We only solved one problem to get the area. We didn't have to break it into pieces. I kind of like this one a little bit better. I see what the book's doing. They try to explain how this works, but I think this is faster. Okay, now keep your notes out. Let's go back to your book. We have two problems to solve. Okay. All right, let's take a look at our first one. Number 15. So I've got, and we'll see if I can draw this here. Here, 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 and then, oh, it's barely a diagonal, isn't it? That's kind of skinny. Okay, I know that these are the heights because look, they said that's a 90-degree angle, so that's straight up and down. So this is 7.5 yards, the height. This base is 3 yards, and this base is 4 yards. Okay, my formula is area equals base 1 plus base 2, in parentheses, times the height divided by 2. Okay, pause it here, go ahead and solve it, and then turn it back on and I'll show you the answer. Base 1 is 3 plus base 2 is 4. And I'm going to put them in parentheses because I have to do that first. Now, does order matter? Could I put 4 plus 3? I can, right? Because this is addition and it's commutative, so order doesn't matter. Okay, now I'm going to multiply it times the height. So that's 7.5. Don't you love it? They love those mixed numbers. Now, if you have a calculator, put it in a 7.5. Oh, I don't have my calculator. My phone is on the stand right now, so we'll have to do this together. Okay, and now I'm going to divide this by 2. Okay, 3 plus 4, I got that part. So this is, oops. Okay, this is 7 times 7.5 divided by 2. Okay, so 7 times 7.5. Okay, so 7.5 times 7, I'm going to do it on the board. You get your calculator and double check me. Okay, I think that's it. 7 times 7.5. So 7 times 5 is 35. 7 times 7 is 49, 50, 51, 52. Decimal goes here, right? 1 decimal place. So I've got 52.5 divided by 2. Okay, so grab your calculator. 52.5 divided by 2. Okay, let's see if I'm right. Aha! 26.25 yards. Okay, so the answer is 26.25 yards. This is a two-dimensional shape, so area is to the second power. If you kept it a mixed number, it would look like this. It would be 26 1/4 yards squared. So this is our correct answer. I think that's a little faster than cutting this into a rectangle and a triangle. We could do it. We absolutely could do it. But this is a little faster. Okay, let's take a look at the last one. Oh, I erased my formula. Okay, I'm on number 14. Here, I'll put my 2 back. Okay, number 14. Okay, so this is one of the ones I was talking about. Your book is trying to be tricky. Okay, I didn't really draw that to scale. Pretend that I did. Okay, I have 3.2 centimeters here. This is 4 centimeters, and this is 6 centimeters. So if you look at our formula, I need 2 bases and a height. It looks to me like they twisted the shape on us. Can you see that? Because there's no base here. There's a slanted line. So that means I need to rotate this shape. So this is actually a base, and this is actually a base. So imagine if I turn this shape, and that's the height. And you know how we know that that's the height? Because it has the 90-degree angles to tell me that it's straight up and down. Okay, so let's plug this in. Okay, so they didn't trick us. We figured it out. So base 1 is 6 plus base 2 is 4. Put it in parentheses. I'm going to multiply that by the height, 3.2. And then when I get that answer, I'm going to divide it by 2. Okay, let's start in the middle. 6 plus 4 is 10. I got that. So 10 times 3.2. Oh, this is that's easy. I'm multiplying by 10, so I'm moving my decimal place 1 to the right. But you could go ahead and put it in your calculator and double check. So this is actually 32 divided by 2. So 32 divided by 2. Well, 30 divided by 2 is 15, and 2 divided by 2 is 1. So 15 plus 1, 16. So this is 16 centimeters squared. You got it. Okay, so that's the answer to number 14. Okay, all right, so your homework tonight. I'd like you to do the practice and problem solving, the next 2 pages. You're going to do 251 and 252, and then you can check your answers tomorrow, or you can check your answers tonight since I've already posted all the answers to the problems, to the homework problems, okay? All right, and then tomorrow we'll go over the guided and independent practice. I'm going to shoot the video a little differently for those, so we'll see how it goes, fingers crossed. Okay, bye guys.